This is the 8th and last video for naming ionic and polyatomic compounds. We're going to do 2 examples here and go through the entire process. All 5 steps are required here for these guys. What we'll do is we'll go through this one first, all 5 steps, and then we'll go through this second one. And I'll ask you to pause the video. You try and figure out before I actually go through the steps with you. So let's do the first one, CrPO4. And we notice that Cr from the periodic table is right there, and that's chromium. So we write down the name chromium, and then we write down PO4. Now when we look at PO4, we notice that P is here and O is here in isolation, but not grouped together in the same box. We're dealing with a polyatomic compound then, and we find PO4 on the back of the list for polyatomic ions, and it says PO4, and that is phosphate. So we write down phosphate. Then we note that, well, chromium gets multiple charges. Well, look at chromium. It can be positive 6, positive 3, or positive 2. Which one is it here? And so we have to write in our name in Roman numerals what that actually is, and we have to kind of go through a process of figuring that out. So, like in the previous videos, you have to reverse the crisscross. All right. So if we write CR, and again, it's an unwritten 1 there, so we put the 1 there, and we've got PO4. We only have one of those guys, PO4s. Remember, we treat polyatomic ions as one thing. We just have one of them. So we reverse the crisscross, and we end up with Cr positive 1 and PO4 negative 1. Again, remember, metals get positive charges and non-metals get negative charges. Then what we're supposed to do is check to see if the non-metal is correct, negative 1. Well, since we're dealing with a polyatomic compound, we check the back of our periodic table and find phosphate. And we notice that phosphate here, PO4, gets a charge of negative 3. Well, that means this is wrong. So we put brackets around it and then write down a number here to multiply it by to get it correct. So if we multiply it by 3, now our new charges are Cr positive 3, because all the charges inside get multiplied by this number here. And then we get PO4 negative 3. So the phosphate is now correct. Now, since we've got this, we finally write our name, chromium 3, and that's Roman numerals 3. And again, we get that on the back of our periodic table. We notice that 3 is Roman numerals 3, so triple I there, and then we write phosphate. And we're done. Okay? Now what I want you to do is pause the video and try and figure out FeCO3. Okay, we're back, and we notice that we've got iron CO3. So let's write iron, and we get that again from the periodic table right here. We've got CO3, so that's carbon and oxygen, but they're not grouped together in the CO3 form here. So that has to be a polyatomic compound or ion, and we find CO3 right there. That is carbonate, so we write carbonate here. Then we have to, because the iron gets multiple charges, we have to reverse the crisscross. So we've got Fe1, CO3, 1. Reverse the crisscross, and what you get is Fe positive 1 and CO3 negative 1. Let's check to see if the charge on the carbonate is correct or not, and we see that CO3 is negative 2. So this is wrong right here. So let's make it right. Put brackets around, multiply by that by 2. So we get Fe positive 2 and CO3 negative 2. Now it's right. Now we write our final name, iron 2 oxide, right? And now we've got carbonate. Not oxide, carbonate. Carbonate. Kind of messed up there, but so iron 2, Roman numerals 2, and then CO3 is carbonate, and now we're done.